Okay, so today we're doing graphing a function rule. So vocabulary and definitions. First one, continuous graph. A continuous graph is a graph that is unbroken. You don't pick up your pencil. For example, in a straight line like that, that is a continuous graph. A discrete graph. A graph is composed of discrete isolated points. You have to pick up the pencil. For example, a discrete graph would be used for something that you can't have parts of. So for example, how many shirts do you sell? You don't sell half a shirt. You don't sell 3/4 of a shirt. You sell individual shirts. So that would have to be discrete items, not a continuum. Solutions are the set of all solutions to an equation of an equation forms the equation's graph. So all the possible x, y's that make a statement true are the solutions. That's what you use to make up a graph. If it's a solid continuous graph, that means everything works. Now, an example. Okay. Problem number one, graphing a function rule. What is the graph of the function rule? So typically when we start to do this, we use a table of values. The idea is here's our x values we put in, and here's our function. That we use, and what we do is we take x and put it into the function. Put in -1. 2 times -1, -2 times -1 is 2, plus 1 is 3. Put in 0 for x. -2 times 0 plus 1 is 1. Put in 1 for x. -2 times 1 is -2 plus 1 is -1. And put in 2 for x. -2 times 2 is -4 plus 1 is -3. These are our x coordinates. These are our y coordinates. Put them together, we get our xy coordinates. And we plot them. -1, +3, 0, 1, 1, -1, and 2, -3. -3. There we go, right there. And then we take and we draw our line through those points. And our line does not end at the points. Our line technically goes on forever. Those are just 4 of the points that make it up. This is not a discrete one. This would be a continuous graph. Okay, next. So problem number 2, graphing a real-world functions rule. The function rule W equals 146C plus 3,000 represents the total weight in pounds of a concrete mixer truck that carries C cubic feet of concrete. If the capacity of the truck is about 200 cubic feet, what is a reasonable graph of the function rule? So the 30,000 pounds, this is what the truck weighs on its own. 146 is what 1 cubic foot of concrete weighs. So possible ones that I have, it's empty. There are 0 cubic feet in it. It's half full. There are 100 cubic feet in it. It's completely full. That's 200 cubic feet. So what we want to do is set up the rule. This is the equation we have, and we take and we plug in our values. So we have 146 times 0 plus 30,000 equals 30,000. So I have the point 0, 30,000. The truck weighs 30,000 pounds even without any concrete in it. And then we do the same thing again. And we put in 100. And we put in 200 for the capacity. So 100 times 146 plus 30,000. That would be 44,600. And yes, I cheated. And if we put in 200, we get 59,000 200, and those are the coordinates we get. And then we plot those points. Now, our scale, we don't have to have ones and whatever. We can do whatever scale we want. On the vertical scale, we go from 10,000, 0, 10,000, 2,000. Each line represents 10,000 pounds. On the horizontal scale, we represent 0 through 200. Top to bottom, these are the points in between. Plot the points. 0, 30,000 pounds. 100, 44,600. Well, 45 is about halfway in between, so it's right about here. And then 59,200, that's just a little bit less than 60,000. Now the question is this continuous or not? Is it possible to have 25 cubic feet? Is it possible to have 32.5 cubic feet? Yes, this is not discrete, so we can connect it all up. That is the maximum. This one does not go on forever because I cannot have more than 200, nor can I have less than 0. Okay, so identifying continuous and discrete graphs. A local cheesemaker is making cheddar cheese to sell at a farmer's market. 1 gallon of milk makes 16 ounces of cheese, and he sells a wheel of cheese for $9. Write a function for each situation. Graph each function. Is it continuous or discrete? So we're going to do the first one, how he makes it. He uses 1 gallon of milk, makes 16 ounces of cheese. So 1 gallon gives us 16 ounces of cheese. So if we use X for gallons and Y for cheese, then Y equals 16 times X if X is in gallons. So X, the number of gallons, 0, 1, 2, 3, 4, and then 5. Y would be 16 times X. So 16 times these. 16 times 0 is 0. 16 times 1 is 16. 16 times 2, 32. 16 times 3 would be 48. 16 times 4 is 64. 16 times 5 is 80. And then we graph those points. 0, 0, 1, 16, 2, 32, 3, 48, 4, 64, and 580. And the question is this discrete or is this continuous? Can he use half a gallon? Can he use 3/4 of a gallon? Can he use 4.268 gallons? Yes, it's not continuous. He doesn't have to add just a gallon at a time. He can use part of a gallon, which would make this a continuous graph. Okay, second problem. He sells the wheel of cheese for $9. So 1 wheel will give them $9. So if I use X for the wheels and Y for the money, Y equals 9X. So X, he sells none, he sells 1, he sells 2, 3, 4, 5. Y would be how much money he gets for each. Multiply all of these times 9. 0, 9, 18, 27, 36, 45. And then plot them. And I'll roll this up so we're not blocked. 0, 0, 1, 9, 2, 18, 3, 27, 4, 36, 5, 45. And the question is this discrete or continuous? Does he sell partial blocks or partial wheels? Most likely not, so this would be discrete. This would be individual points. He probably has it prepackaged and sells just by the wheel alone. That's the implication. Okay, last one. Graphing non-linear functions. So here's what I want you to do. I want you to take these numbers for x and plug them in to the equation and figure out what your y coordinates are. Now, which means you're going to put -2 in here. What does the absolute value do? Absolute value does not change the sign. Absolute value just makes it positive. If it's already positive, it stays positive. If it's negative, it becomes positive. So I have -2. Absolute value of -2 is 2. 2 minus 4 is -2. Plug in the other numbers. And if I go down here, absolute value of 2 is 2. 2 minus 4 is once again -2. Please take a couple of minutes, fill in the rest of the table, find the corresponding XY point, and plot them. Okay, so y equals -1, y equals the absolute value of -1 minus 4. Absolute value of -1 is +1. +1 minus 4 is a -3. Put in 0, absolute value of 0. 0 minus 4 is -4. Put in 1, and guess what? I get -3 again. This is what absolute value does. So these are the coordinates you get. And then you plot those points on your graph. -2, -2. -1, -3. 0, -4. 1, -3. And 2, -2. And this is not a discrete graph. This is continuous. And it goes on. And this is what an absolute value graph looks like. Absolute value graphs are always a V shape. Always a V shape. Okay. So we're going to do the same thing on the next one. Fill in the table. Use these points for x, the same coordinates. And then this is the equation you're going to use for y. Now, order of operations. Plug in -2. You take -2 and square that, and then add 1. -2 squared is 4. 4 plus 1 is 5. And then you're going to take -1 and square that and add 1. Take 0 and square that and add 1. Take 1 and square it and add 1. And take 2 and square that and add 1. You're going to get your first coordinate for this one would be -2, 5. So take a minute, fill in the rest of the table, square them, add them together, come up with the coordinates, and plot the points. Okay, so finish things off. -1 squared is +1. 1 plus 1 is 2. 0 squared is 0. 0 plus 1 is 1. 1 squared is 1. 1 plus 1 is 2. 2 squared is 4. 4 plus 1 is 5. Same kind of setup as what was there before. These are the coordinates you get. And then we plot them out. -2, 5. -1, 2. 0, 1. 1, 2. And 2, 5. Now, this is x squared. This is called a quadratic. Quadratics give us a parabola. Parabolas are a nice U shape, not a V shape. There should be a U at the bottom. Absolute values are V's. Parabolas or quadratics are a U shape. We're going to do a lot of work with those coming up mostly next semester. But these are important to get into. U shape, V shape. Okay. Enjoy and get ready to do your work.